In public health research, many important variables are categorical. For example, smoking status, disease presence, or exposure categories. A common research question is whether two categorical variables are associated. The chi-square test is used to evaluate whether the observed relationship between variables is likely due to chance. The chi-square test is appropriate when both variables are categorical, observations are independent, and we want to test for association, not difference in means. Our goal in this analysis is to see whether smoking status is associated with hypertension, also known as high blood pressure. First, we load two helpful R packages, readior and dplyr. Readior helps us quickly import data, and dplyr helps us clean and transform it. Next, we load a dataset into R and store it in an object named nhaynes. Now we create a new variable called hypertension. We use the mutate function from dplyr to add a new column. If a person's systolic blood pressure is 140 or higher, we label them yes for hypertension. If it's below 140, we label them no. Why 140? Well, in public health, systolic blood pressure of 140 millimeters of mercury or higher has traditionally been used as a threshold for diagnosing hypertension in many guidelines. Creating this binary variable makes it easier to compare groups. Next, we create something called a contingency table. This table shows how many people fall into each combination of smoker versus non-smoker, hypertension versus no hypertension. It's a simple but powerful way to visually inspect whether smoking and high blood pressure might be related. Let's take a closer look at this contingency table examining smoking and hypertension. Here, we're comparing current smoking status to whether someone has hypertension. In this table, 0 means the person is not a current smoker, 1 means the person is a current smoker, no and yes refer to whether the person has hypertension. At first glance, we can already start thinking like epidemiologists. Among non-smokers, 755 out of 5,230 people have hypertension. Among smokers, 154 out of 884 people have hypertension. If we quickly estimate the proportions, in non-smokers, about 14% have hypertension. In smokers, about 17% have hypertension. That suggests hypertension appears slightly more common among current smokers, but here's the key public health takeaway. A table like this shows us the pattern, but it doesn't tell us whether the difference is statistically significant. That's why we follow up with a chi-square test. The chi-square test helps us answer this key public health question. Is there a statistically significant association between smoking status and hypertension? In other words, are the differences we see in the table likely due to chance? Or is there evidence of a real relationship? Now let's interpret the results of the chi-square test. This is a Pearson's chi-squared test with Yates's continuity correction. The continuity correction is automatically applied in 2x2 tables like this one to make the test slightly more conservative, meaning it reduces the chance of falsely detecting an association. Here are the key results. Chi-square statistic, 5.09, degrees of freedom, 1, and p-value 0.024. So what does this mean? The p-value tells us the probability of observing a difference this large or larger if there were truly no association between smoking and hypertension in the population. Because the p-value is 0.024, which is less than the standard cutoff of 0.05, we consider this result statistically significant. In plain language, there is evidence of an association between current smoking status and hypertension in this sample. This means the difference we saw in the contingency table is unlikely to be due to random chance alone. However, it's important to think like a public health professional. This tells us there is an association, not necessarily causation. We haven't adjusted for other factors like age, sex, diet, or physical activity. And also, statistical significance does not always mean clinical significance. Still, this result suggests that smoking status may be related to blood pressure outcomes, an important finding for population health research and prevention strategies. We also look at test expected. These are the expected counts, the numbers we would expect in each cell of the table if there were no association between smoking and hypertension. In other words, this is what the data would look like if smoking status and hypertension were completely independent. Now let's talk about the expected counts from our chi-square test. Here are the expected values. For non-smokers expected to have no hypertension, about 4,452. Expected to have hypertension, about 778. For smokers expected to have no hypertension, about 753. Expected to have hypertension, about 131. Now let's compare those to the observed counts we saw earlier. Among smokers with hypertension, we observed 154, but we expected about 131 if there were no association. That's more cases than expected. Among non-smokers with hypertension, we observed 755, but we expected about 778. That's fewer cases than expected. This difference between observed and expected counts is exactly what the chi-square statistic measures. The larger the gap between observed and expected values, the stronger the evidence that an association may exist. One more important note, all expected counts here are well above 5. That means the assumptions of the chi-square test are satisfied, and we can feel confident that the test results are reliable. So in summary, the expected counts show us what no relationship would look like. The fact that our observed numbers differ from those expectations supports the statistical evidence that smoking and hypertension are associated in this dataset. This is how we move from raw numbers to meaningful public health insight. In the next video, we'll explore relationships between continuous variables using correlation and simple linear regression. These methods are commonly used to study relationships between public health indicators.